if I refresh maybe. Go live, go live. Testing, testing. Let's see. First time doing a scheduled YouTube live stream. Just want to make sure that I actually see. I need to make sure I actually see the stream. I don't see it yet. Let's see. Go live. Are we live now? Live right now. Are we showing the stream view? Oh, is it maybe because... Oh, there you go. Okay, I think we have something now. I don't see it yet. Okay, I think we're live. Took me a second. Not entirely used to this yet, but this is good. Okay, so everyone, welcome to LeetCode Live. Today is Monday, July 25th. We're going to start off with some problems. Hope to see a couple of new viewers here. I know I made some posts today around the interwebs, so I'm hoping that we get some new faces today, some new viewers. I think it'll be a lot of fun. Yeah, I've been having a lot of fun with this YouTube live thing. One of the reasons I brought it on YouTube, I started off doing this on Reddit first, but then I decided to just do everything on YouTube since I end up uploading everything here. I think it makes it easier for people that are watching, especially on mobile. Like the streaming on Reddit is not very mobile friendly, so it makes it hard for mobile viewers to be able to view the code and whatnot. But on YouTube, not only desktop viewers can watch it, but mobile can as well. So just a little bit of background about myself before we get started, just in case there's anyone new here. So I started doing this last week. It's already been over a week, which is pretty neat. And my intent was I didn't really want to I didn't want to make a channel to necessarily teach LeetCode. I mostly wanted to create a channel to show myself going through every single LeetCode question. And reason being, for myself to practice and speaking out different problems and whatnot, but also to hopefully show people how I approach problems, hopefully get some community interaction, talk with you all, see what sorts of things you're struggling with, and hopefully you all learn a thing or two, and I would also learn a thing or two. So that's really it. Like on the YouTube channel, if you visit my YouTube channel, so let me go right here. On the YouTube channel itself, I have sort of like an introduction video that you can watch, which it should be showing up here. Maybe it could have been the case that I like accidentally removed it, but it's this one right here. It's called Watch This If You're Crazy Enough to Go on This Journey with Me. And it just gives you a little bit more background as to why I started doing all this in the first place. So check that out if you're interested. And hopefully, all that will work out like really well for you. Okay, sweet. So without further ado, let's just get right into it. So I normally sort this by acceptance here. Right, so you can see here we've done like a lot of different questions already. Like we've been doing this for a while. I think last I checked we're on 67, so that's all pretty good. Let's go over here and start looking at the, I think, increasing order search tree. I don't know if this one, I think we left off on this one yesterday. Yeah, this one, so normally what I do is I have this list of questions that I revisit. I like to do this maybe like once a week on a Saturday. I look at this list and go to all the questions that I add to here. This one was pretty tricky and I couldn't figure this one out. I mean, I know there's like a fine line between watching me struggle too much and then not going through any questions at all. But if you all really want me to do this one, we certainly can. But today we can start with this one, merge two binary trees. And we can sort of see what we get from here. Let me know if everything's good with like the lag, or if there's any lag, or if you feel like you can, if you're watching me okay. I just want to sort of like keep checking with the community. Like I said, I'm still like fairly new to this, so wanting to make sure I can make this stream the best that I can. Okay, so let's go through this. So we're given two binary trees, root 1 and root 2. Imagine that when you put one of them to cover the other, some nodes of the two trees are overlapped while the others are not. You need to merge the two trees into a new binary tree. The merge rule is that if two nodes overlap, then sum node values up as the new value of the merged node. Otherwise, the not null node will be used as the node of the new tree, and then we can return the merged tree. Merging process must start from the root nodes of both trees. So do we have, let's see, like if at any point we get to let's think about this. We have like two different trees here. If we start, I think we can do like a pre-order traversal here. I think we can just operate on them like as soon as we get to each different node. Sometimes what I like to do is I might do like a post-order traversal where I visit a node, but then go to all its children first, get some information, give it back to its parent, and then the parent can use that. But I think in this case, we can just sort of follow what it said. So let's see if just by doing that, we can get like a semblance of what they want us to do. So if two nodes overlap, then sum the node. Otherwise, the not null node will be used as the node of the new tree, right? So if we have a node that's null, then we should just return the other node. And I guess we're not sure if that'll be null or not, but we just know we should return the other one, right? So I think we can do, for example, if not root 1, we can return root 2. And then if not root 2, then we'll go ahead and return root 1. And then here, if two nodes overlap, then sum node values up as the new value of the merged node. So here, can we just do root 1 dot value plus or equals root 2 dot value, assuming that both nodes are, like, if either of them were null, it would have come here, but at this point both are null. So could we do root 1 dot left equals merge trees root 1 dot left and root 2 dot left, and then root 1 dot right equals merge trees root 1 dot right and root 2 dot right, return root 1. Let's see what this gives us here. Root 1 dot right, did it not like this merge? Oh wait, merge tree is not, oh, merge trees, okay. That was just a typo on my end. 34554 null 7. Let's try some other cases here. I'm very used to dealing with premium. I feel like I say this on every stream, but it's just how it is. Like, I'm very used to doing 2 premium, so like sometimes I'll just spam that. Could we, let's see, we're on normal latency right now. It would be nice if I can modify that midstream, but I suppose not. We'll see how this is once we're done here. So let's submit this. Okay, 54.12. Submit it again to see if like that time will change. 72.50. Now this is a normal binary tree, so there's not like some special property we can take advantage of. For example, if it was like a binary search tree, maybe that's something that we could take advantage of. But here, since it's just a binary tree, to me it seems like we'll need to at least visit every single node to go through this merge process. So because of that, I'm comfortable saying this is a linear time complexity, or O of n, where n is the amount of nodes in this tree. And then for space complexity, really we're just dealing with the height of the tree, right? In the case that we have like a heavily skewed tree, you can imagine if we have a tree that's, only right pointers that starts sort of looking more like a linked list, that stack might grow to be O of n, again, where O of n are the amount of nodes. But in this case, since at least this tree, things are looking pretty balanced, then we would expect for that internal stack to only grow as large as the height of this tree. So that's how I would categorize this one. So yeah, feel pretty good about this one. Let's go ahead and continue. Let's see, merge 2. Okay, next one here. Minimum operations to make the array increasing. So we're given an integer array nums 0 indexed. In one operation, you can choose an element of the array and increment it by 1. For example, if nums is 1, 2, 3, you can choose to increment nums nums 1 to make 1, 3, 3. Return the minimum number of operations needed to make nums strictly increasing. Okay. So let's think about this. We have like a couple of different So if we want to make it strictly increasing, that means every next value needs to be greater than the previous value, right? So like here, what if we had like a pointer that starts right here, and then, well, I guess we don't even have to start at 1, right? Like if it was just an array of size 1, we can just immediately return that. Now if we go here, let's see, this would be, you say is 1 greater than or equal to, or if it's, I guess if it's less than or equal to this one, then we just increase it by the difference. Right, well in this case the difference is 0, so just increase it by 1. This would be 2. Now we come over here, it's less than or equal to, what's the next greater number after this? So we can say like next greater number is 3. So then we increase it, like increase current by current plus difference, or next greater minus current. All right, so we increase this one by 3 minus 1 by 2, and this becomes 3. So I think this one, I think that's how we should do this one. If we do 15241, let's try to use that. So 15241, we'll start here. Okay, so this one's greater, so it's fine. It's only if it's less than or equal to. So this one's less than or equal to. The next greater one is 6, right? We add 1 to this one, 6. 6 minus 2 is 4. So that's going to give us a 4 right here, and this becomes a 6. Here, the next greater one is 7. 7 minus 4 is 3. We make this a 7, and we add 3 here for a 7. The next greater one is 8. 8 minus 1 is 7. So now we add a 7 to here, and that gives us 14. So I think we can start it off like this. So let's see, let's say operations equals 0. We'll start at I equals 1, right? And why are we starting at I equals 1? If I equals 1, like if we have an array that's just empty or just 1, like both of these are already like maximum. So if we just start at 1, that will already take care of both of these different cases. So just like something good to think about there. So if we let I equals 1, I less than nums.length, I plus plus. What is it that we want to do here? I think I maybe added too many braces. Okay, cool. So let's say if nums of I is less than or equal to nums of I minus 1, then we can say the next greater equals nums of I minus 1 plus 1, and nums at I equals next greater minus, or actually no, nums of I plus or equals next greater minus nums of I. And then we sort of want to do the same thing, right? Operations. We want to also add that same difference. Operations plus or equals next greater minus nums at I. So if I can save this, what would be, I guess that's a good way to go about it. I'm pretty happy with that. And now thinking about this, we can actually reduce this whole thing. Let's see if we can write that with a reduce function once we have this one. Return operations. Let's run this code. 0 and 3, interesting. So if nums of I is less than or equal to, so we get here, that's greater. 2, this is less than or equal to nums of I minus 1. So the next greater is nums of I minus 1, which is 5, plus 1 is 6. Nums of I is equals to 6. We get to 6 minus nums of I, that's 4. Nums of I plus or equals 4 makes this a 6. And then we do operations plus or equals next greater, which is 6, minus, oh, yeah, we want to first do, we should probably do this before we set nums I, want to make sure we do operations first. So that's 3 and 3. For the next two, 3, 14, 0, 3, 14, 0. So let's go ahead and run this. Okay, 50%. That's like right on the money. I've actually not ever really seen that before. So that's kind of cool. Just like seeing the 50% exactly. 57.20. $58. So it's almost like it's consistently just right in the middle. I would like for it to see if we can get it to be a little bit better. Okay. Okay, I see. Okay, so this one was a little better. Let's see what the discussions have to say. I'm very curious. 3 track last. Oh, so instead of, I did like this. Sure looks cool. Well, I mean, this is kind of the same, right? We could just do last. Because what he's saying, track the last one. 1, 1, 1. 1, 5, 2, 4, 1. I feel like both things are the same. I'm not really too convinced to try out the other way, so we can just continue here. All right, destination city. So we're given the array paths where paths of I. So paths of I, city A, city B means there exists a direct path going from city A to city B. Return to destination city, that is the city without any path outgoing to another city. Okay, so it's guaranteed that the graph of paths forms a line without any loop. Therefore, there will be exactly one destination city. Okay, I think this one is going to make a lot more sense if we draw it out. So let's remove this. I want to open my text tool here and make this larger. Also give it, I always like this color. Okay, so let's start drawing some circles like we have here. London, we'll have New York, we'll have New York, Lima. So London, New York, this is New York, this is Lima, and then Sao Paulo. So I guess we can London, New York, Lima, SP. So we have London to New York, and then New York to Lima, Lima to Sao Paulo. So it just wants us to follow some path. Starting at London, you will reach Sao Paulo. Okay. All possible trips clearly to destination. So B to C, DB. Okay, I think this one just makes like too much sense. This is a very contrived example. I think we should try to expand a little bit here. So this is like 1. I'm just going to move this around. Okay, so let's say we have B. Kind of make this circle a little bit better here. We have B, C, D, and A. B, this is going to be C, D, and A. So let's do this now. So B has a route to C, D has a route to B, and C has a route to A. Okay, so we want the node that doesn't have, I think we can just do the node that doesn't have any children. Right, or any neighbors. I think that's the way. I don't even think we necessarily have to make, we can sort of make our own, we can make an adjacency list really. Right, and is this always going to be 2? So I think what we can do is we can go, what if we made, let's say const destinations is equal to an object literal. We can say for const path of paths, here we can say const source and destination. We'll use using some array destructuring to make this really nice. Here we can say that if destinations, right? If destinations at source is equal to undefined, then we can say destinations at source equals an empty array. And we can also say, now does it necessarily mean, this is just a source to a destination, right? Yeah, if source if destination source equals undefined, okay, then I think we should just say destinations at source dot push destination. So we should end up with an adjacency list, and now we just want to find the one that doesn't have. I think what we can do is, what if we were just to go through each one, like for const source destinations of object.entries of destinations, right? Here we can say if destinations.length is equal to 0, return source. I think we can do this, and it's a guarantee that there will be one. Exactly one destination. So I'm curious to see what this sends over. Object entries of destinations. Let's see. Object entries of destinations. Why did this not work? Object entries returns an array of object entries object 1. Okay. For const path of path, we get the source and destination from the path. Destinations.source cannot access destinations before initialization. That's a very interesting error. Maybe, am I using this? Oh, okay, here we go. For const, yeah. Maybe here we should say, let's just say dest. And here we'll say src to keep them both small. Here, let's return src. Undefined. So let's go ahead and print out console.log destinations. London, New York, Lima, Lima, Sao Paulo. Oh, but then we're not, I think Sao Paulo doesn't go anywhere. Okay, so let's think about this. We can't just always add. Should we just add London to New York to Lima, Lima to Sao Paulo? Should we just always add the destination as we're going through this? Is that the only way that we're gonna know? I want to think of like a nice way of solving this, not just like, I see that I have a source to a destination, so I want to add this path in my array. But now should I also add maybe the destination? Maybe I should automatically include the destination, but with no neighbors. Could we do that? Like inside of here, I can say if destination source is equal to undefined, we're gonna push that. But maybe we can also say destinations of destination equals empty array. Let's see what this does. Okay, so that's fine. Now we do get Sao Paulo. The last one should be Z. Sao Paulo BZ, Sao Paulo BZ. And this time we got, let's see. This one, destination. Should we only ever do this the first time? Let's go through this one again. So if we go to this one over here, I create a source to a destination, but then I also create an empty for my destination. So let me start writing all this out. We have this here, right? We have B that goes to C, but then I also immediately want to create a C that has nothing. Then I go from C. So when I get to C, I see that it already exists. I get the destination. Oh, I think I see what the issue can be. I get the destination, which is A. I create an empty array, but then I push A to here. and then we go D to B. Wait, B to C. Oh, I did this backwards. Let's do this. B to D, and then we have D. It's not in there, so we immediately do this. We also create, yeah, D to B should not, D goes to B, but B shouldn't, yeah, I think if B already exists, do nothing with it. So if we do if destinations at destination not equal to undefined, right? If it's not equal to undefined, so we found the B, or I guess we can do the same thing here. If it's equal to undefined, we set the destination. We only do that one time. Let's see what this gives us. Which, if Sao Paulo AZ, Sao Paulo AZ. Okay, so if, I guess this is, so I'm trying to understand this for my own. Like, if this does work, let's see if this works. Okay, 23.87. But let's see, is there like a better way that I can do this without creating this map? Maybe instead of doing all this logic, I mean, I would still like to go through each one, maybe without doing this. So like, why does that work? I create destination to source and destination to destination. If that's undefined, I'll also create it in my map. So B to C, create B to C, and then I create C. And then I get to C and I push A, then I get to A, then I go D, push D to B. B already exists, which means it already has a destination, so don't do anything, don't overwrite it, and then we just end up with A. It seems a little bit slower than I'd like. 45.16. It might be because we might not need to, I might not need to create that map also. Right, like I just kind of realized the pattern. Like in both of these, there's only one that appears once, I guess. So can we just keep track of the one that appears once? Let me try to kind of do that. Let's see. I want to comment this whole thing out. What would be a nice way for me to, I mean, heap could maybe be nice, but let's do const path frequencies for, this is going to be all over the place now, for const path of paths, path frequency, we can do the same thing in here, const source destination equals path, and now we'll just say path frequency of source equals, we're going to say path frequency of source plus 1 or 1, because we're counting frequencies here. And then we'll do the same thing for destination. All right, so now we have a frequency, so we just need to return the one that only shows up once. So let's see. I don't want the values, I still want, so if I do return object.entries of paths, so this is going to give me back an array, a 2D array. So can we do find, I think is find the one, like mdn array find, first element that provides the testing function. So I want to find a path where path at 1 equals to 1, and this is source destination. I wonder, this looks, I know this looks crazy, but I'm just so curious. Path 0. Yeah, undefined reading 0. Path of 1 equals 1. What would be the nicest way for me to do this? How many paths do we got? Wait a second. I think I saw something about all strings consist of lowercase and uppercase English characters and the space character. Pass dot length, city length, 10. Let's see. What do we have here? Const path frequency. Oh, let's console log this. Console.log path frequency. I'm going to comment this out. Just want to see the output of this. Oh, A and Z are 1. So it's not just... Yeah, it might be a similar thing, right? There's some sort of logic that I'm missing here. Because London, New York, Lima. No, actually, that won't work. Because London and Sao Paulo both show up 1. So we only want the one that has no children. Yeah. And the source goes to destination. Source goes to destination. D to B. Nothing goes to D. D goes to B. B goes to C. C goes to A. Would have been nice if we just had, but then we never include the A. So we also need to make sure that we include the destination and just mark it as not having any neighbors. Cool. Increasing, decreasing string. That's a nice question. It's like it's not really, I wouldn't say it's like graph oriented per se. I want to see the discussion. And I want to upvote this because I like this one a lot. Java tricky lines. Okay. Using one set. Destination city will always be the right one. We traverse the input for 2 times. First time we add all the cities on the right side to a set. New York, Lima, Sao Paulo, London. Second time we check if the city occurs on the left side. If so, remove from the set. Result will be the city left in the set. A difference. Okay, clean Python. This is a set. Hash set. Insert if not starting cities. Simple and natural to what we are searching for, plus easy to be debugged for potential issues. To prove the point, I also provided the other 3 popular solutions at the end of the post. Okay. T1 break. Destination city. I want to see one that uses like, this is a map in a set. If it's the start of the path, make the value +1. If it's the end of a path, make the value -1. Just to mark. The thing about some of these LeetCode descriptions is like as soon as there's one that's marked highly, all the other ones are just going to be variations of this one, so it's hard to find the next different one. Okay. Increasing, decreasing string. All right. Let me just check on one thing real quick. All right, everything seems good. Pretty happy with everything, so let's keep it going. So you're given a string S, so bad like to dislike ratio. I'm not too happy with that, but let's see what we can do. So you're given a string S, reorder the string using the following algorithm. Pick the smallest character from S and append it to the result. Pick the smallest character from S, which is greater than the last appended character to the result, and append it. Okay. I'm gonna skip this one because this one just seems this seems like you just have to do what this says, and I'm not sure that provides any value to me. I will do it before I ever, like my definite one thing is before I ever go to the next page here, we will have done every single question, which I can't believe we're almost to the end of the first page. That's incredible. Okay, determine if string halves are alike. You're given a string S of even length, split the string into 2 halves of equal length and let A be the first half and B be the second half. 2 strings are alike if they have the same number of vowels. So book, 1 has and B has 1 vowel, therefore they are alike. Textbook, okay, so we just take text and book, and then we compare the frequencies of each one. That's like the best way to go about it. Now, if I'm only counting vowels, let's see. Does that necessarily mean that they have the same number? Because this doesn't have like BAA, so they need to like be inside. If here is one I found in there, then we can decrease the counter. So let's say I want to create like a vowel counter. Vowel counter equals 0. And let's say vowel map for the first one. Let's say 4. So if I take, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. Divided by 2 is 4. So I go to 3, 0, 1, 2, 3. So 4 minus 1, and then I start. Yeah, so let's say let midpoint, or we can just do for let I equals 0, I less than math.floor of s.length divided by 2 minus 1. Or no, we can just do this. Math.floor I plus plus. Here we'll say vowel map of s at I equals vowel map of s at I plus 1 or 1. And we can also say, no, actually wait, we need to make sure it's a vowel, right? I'm going to take advantage of regex here, so we can say vowel regex. We'll create a new regular expression for this, and I think what we can do is AEIOU, make it case insensitive. So here we'll say if vowel regex.test s at I, we'll go ahead and increase it, and then we'll do vowel count plus plus. Okay. And now here we can do for let I equals, again, math.floor I less than equal to s.length I plus plus. We'll do the same thing. If vowel regex test, if it's a vowel. So if it's a vowel, and here I want to say if it's a vowel and vowel map, say vowel map at si is not equal to undefined, then let's say vowel count. Now do we want to say, let's see if they have the same one vowel, whereas B has 2, therefore they are not alike. So we enter 1E here. A has 1 vowel, whereas B has 2. Oh, do they just need to be? Oh, they don't even need to be. They just need to have the same number of vowels. They don't need to be the same vowel. Okay, let's not make this case insensitive, since it seems like it doesn't want us to do that. So vowel count is 0. If it passes, I don't even think we need the vowel map. Here we can do vowel map plus plus, and then we'll do the same thing here. We'll say vowel map minus minus, or vowel count minus minus, and then we can just return vowel count equals to 0. Let's like go through this. So here BO, so O is 1, and then we subtract 1. Okay, cool. Text and book. AEI, so E, and then we do 2. That makes it -1. It's not 0. But you know what? You know what we could do actually, and I just realized this. This is gonna be cool. We can do this whole thing in one loop. We don't even. Yeah, we can say start equals 0, let end equals s.length minus 1. And actually, wait, before I do that, let me run this to see if this is even right. True, true. Get to this next piece here. True, false. Let's run this code. False and true. Oh, A, E, I, O, and U. So is this not? So I equals 0, that's 2. I less than math.floor of 2 divided by 2 is 1, I plus plus. If it passes the vowel check, vowel count plus plus, then we start at 1. Math.floor of 2 divided by 2 is 1. If vowel regex test true. Wait, false? Does it not like... If they have the same number of vowels, A can notice that S contains uppercase and lowercase letters. Number of vowels. But do they need to be the same vowel? Same number of vowels. A, E, I, O, U, A, E, I, O, U. Are we not? Shouldn't this be? Oh, maybe it should be, okay. I guess, should that really matter? Let's see if we copy this one. True, false, true, true, false, true. Okay. Okay, so maybe it was just the, I guess I needed to make a case insensitive, but check this out. Right now we're iterating, although we're still only going through both halves, it might end up being the same, but really we can just go, so we can say let I equals 0, let end equals s dot length minus 1. We can go as long as they're less than each other. Right, so while start could we do that actually? Oh, I was really hoping we could, but no, they would both have to go at different speeds. How could we always, or we can just do each side. No, actually this might still work. While start is less than end. Now here we can just do this. Let's remove all this stuff. We can even make it more condensed. Copy this, copy that. Here we'll say start, here we'll say end, and then we'll do start plus plus and minus minus. Vowel regex, vowel counts. Does this still work? Oh, did I not? Start plus plus and minus minus. Well, start is less than end. Start 0, end is s dot length minus 1. Wait, why did that time out? Or it's seemingly timing out. Oh, true, false, true, true, false, true. Wow, that took a very long time. 68.78, right? Because just by the nature of this, right, we're always going to end up in the midpoint. And if it's an even length string, we can just take advantage of this two-pointer technique and just have to go inwards once. I guess it's still, it really is the same amount of time, I think, right? Because in the first loop, I was only going up to the midpoint, and then I was going from the midpoint to the end. So I was only doing a single traversal. But I think this is a little more elegant here. So here I would say this is linear time. No, actually not even. We don't have to. We're only going through half the string. S divided by 2. And then space complexity is constant. So I think that's pretty neat. All right, cool. Reverse the prefix of a word. I think we're doing pretty good here. I'm happy with the amount of questions we've covered today. All right, so given a 0 index string word and a character ch, reverse the segment of word that starts at index 0 and ends at the index of the first occurrence of ch. For example, if word is A, B, C, D, E, F, D, ch equals D, then you should reverse the segment that starts at 0 and ends at 3. Okay. So really, I think we can have, okay, so we have a string. So the first thing we need to do is create a copy because strings in JavaScript are immutable. We use the spread operator to do that. And now what we can do is we can say for let I equals to 0, I less than word dot length, I plus plus. If, let's see, if word of I equals ch, then we'll say ch index equals 0. Here we'll say ch index equals I. And then really we just need to reverse them now, right? So in the easiest way, we can also just do for let I is less than word.length. If it equals, that's fine. Is there any way? I guess if we never find it, it'll just be 0, and then we won't reverse anything. So I is equal to 0, j is equal to ch index, I less than j, I plus plus, j minus minus, const temp equals, let's see, copy of 0, or copy of I, whoa, messed that up. Copy of I equals copy of j, and then copy of j equals temp, and then the rest should be handled for us. So let's return, here we'll just do return copy.join. See what this gives us here. Wait, okay, df, okay, interesting. dfe, so ch, I started at 0, 0, 1, 2, 3. ch equals I. Oh, we never broke. That's definitely gonna impact us. dcbaefd, let's go through some more test cases. z, x, y, x, x, e, a, b, c, d, submit. 73.91. So yeah, pretty much just like it says, like we have to create a copy of this word because it's a JavaScript string. They're immutable, so we can only operate in a copy. So this might increase our time and space complexity, or space complexity, to n, since now we're having to keep track of this. But the rest of this is also linear space complexity, since we're having to, let's say at the worst case, go all the way to the end to find it and reverse the entire string, right? We find the index where ch index is at, we set that equal to the I, and then we break, and then we just have a normal, like a standard reverse loop going from I to j index. We can maybe condense this, although it'll make it a little harder to read. I think we can take advantage of some fancy JavaScript syntax here. So we can say copy j, copy of I. Okay, let's do this. See how that looks. Yeah, seems like the same result. Maybe just a little more condensed, 20.7, maybe even worse performance. But again, I'm happy with this. So yeah, we can go ahead and continue to the next one. So determine color of a chessboard square. You are given coordinates, a string that represents the coordinates of a square of the chessboard. Below is a chessboard for your reference. Return true if the square is white, and false if the square is black. Okay, and I guess the chessboard is always this length, right? Okay, so there's definitely some formula here. I guess like A is going to be A1, H3, A1, and will it always be given C7? Okay, so the first one will always be, okay. So we need to find out where any of these lies. What we can do is quickly get like the index of this, right? Anytime that it's, let's see, first I want to find out if it's like an even column or odd column. So let's say, let's do column and row. We'll say column and row equals coordinates. And unfortunately, this is just a string. So let's spread this coordinates to get our column and our row. Now let's first decide if it's an even or odd row. So if, let's create some functions here, like is even column. This can take column and it'll return column divided by 2. Oh, but wait, we need to pass in the column's going to present what? Yes, that's going to represent a string, right? What I need to do here is get the index of it and normalize it. We can do that by doing col.car code at 0 minus 97. Let's say this is just like const index. Here we'll say return index modulo 2 equals 0. All right, so here we can say if is even col, we'll pass in our col. We can do something else. We know it's odd. And now we just need to get the row. So we can do something very similar with the row. However, here, this is a string. So we just need to parse into this. So here we just should be able to do return parse int of row, pass in the radx, similar function here. So here we'll call this if is even row. Okay, so if it's an even, and now there's like different things that we can do, right? What happens if it's even row? So even column, even row, odd column, even row, or even column. Wait, I'm getting mixed up here. Let's do row, column, 1, 2, 3, 4 column, or 1, 2, 3 result. This is sort of like a truth table. So we'll do 0, 0, 0, 1, 1, 0, 1, 1, where 0 equals even and 1 equals odd. Okay, so if I have an even row or an even column, so A1, and it's going to say return true if the square is right, if the square is white. Okay, so even column, yeah, let's say, even column, even row. So 0 even row is going to be black. False if the square is black. Here we have an even row, or odd column, even row is going to be true. Here we can say, let's see, 1, 0. So we have an even column, odd row. That's true. And then here, if we have an odd column, like 1, and an odd row, that's false. And now I'm thinking about this. Isn't this, oh, that'd be so nice if we can do, or I mean, we can, no? I wonder. Could we just do, is this X and? No, not Lil Xan. X and, right? Because there's an XOR, there's an exclusive and. False, true, true. No, this is exclusive OR. This is exclusive OR. So can we just do the exclusive OR of both? Like if we have an A1, wouldn't that just be 0, 1? And that would be 1. If I have H3, that would be 0. Oh, but this is all normalized. So 1, 2, 3, 4, 5, 6, 7, 8. So we'll do column 8, 3. Which is, oh, well, that represents 11, which who even knows what that means. Oh, and this would be nice if somehow, if it's even or odd, how do I want to do this? Every single even, well, yeah, if the number that we get, we can just transform it. And if that's even, we return a 0. So maybe here we'll just say, instead of H, okay, maybe here we can return, or get parity of num. here I'll say num modulo 2 equals 0. We'll return 0, else we'll return odd. I think what we can do, like const row, const column parity, can remove all this stuff. The call from coordinates will always be, it will always be a string. So I'll need to do get parity. In here, I need to pass in that string, col.car code at 0, and I'll do minus 96, so it's normalized. So if this is a 1, right, that'll be an odd column. Oh, but I sort of messed this up, right? If it's an odd column, if it's an even column, 1, 2, even column, even row, it's going to be true. 2, 2. If it's an odd column, like 3, 1, 2, 3, odd column and even row, it's going to be false. If it's an even column 2, odd row, that's going to be false. And then odd column 3, 3, that's okay. So odd column 3, 3, that's true. True, false, false, true. So this is X and true, false, false, true. So how do we do X and in JavaScript? Whoa. X and in JavaScript. XOR is exclusive OR. Guys, don't scare. Okay. Is there a way to do like logical? Why is there no X and operator? Wikipedia mentions NOR though, which has exactly the same truth table as what you'd call X and. The exclusive in XOR means that we exclude the case where both inputs are true. The current binary 1001. So do we just flip? I made this a little bit more difficult than it needed to be. I started going into this rabbit hole, but it's pretty exciting. Here we can get the parity of parse int row 10. Yeah, parse int row of 10. So let me just see what this gives us. Console col parity and row parity. We should get either zeros or ones here. So A1 is 1, 1. Okay. One, 1, 0, 1. 0 is even. That's even. 3 is okay. C is odd. 3, 7. Okay, so I think what if we just return the opposite? Return like not col parity and row parity. Could we do this? This could be a good way. So true, false, true. False, true, false. Let's see. This will either return. Let's do both things here because we saw for sure that it was not an XOR, right? False, true, false. Wait, is it XOR? No, that didn't seem. 27.57. Okay, I could have sworn we proved it was not an XOR. But true, false, false, true. If that returns a 1. Oh, I guess it's just because, okay, I see. How is there something that's even faster? Solution, I wonder. Will anyone mention that? I'm sure they will. C++ one-liner. Wow. Modulo 2. Python one line. Okay, so it looks like I made it more complicated than it needed to be maybe, but I'm happy that I was able to use bitwise manipulation. I feel like that's just a good thing for me to know. Calculate the sum of row and column coordinates. Check if it is even. If yes, return true. Otherwise, return false. Okay, that's cool. I'm happy about my solution. I think it's pretty neat. It's constant space complexity and also constant time complexity. So very happy about that. Cool. Let's see if we can do one more. I normally like to finish right at the top of the hour. Let's do maximum number of pairs in an array. Okay, so you're given a 0-index integer array nums. In one operation, you may do the following. Choose 2 integers and nums that are equal. Remove both integers from nums, forming a pair. Okay. Does it matter? Does it have to be 3, 1? What if, I'm just going to see what happens if I were to sort this. So if I sorted this, it would be 1. We have a 1 and we have another 1. We have a 2, 2, 2, and we have a 3 and 3. Formed number of leftover integers. So why would we have a 1 left? In one operation, choose 2 integers and nums that are equal. Remove both integers from nums, forming a pair. See, so I thought we can do 1, 1, 2, 2, and then 3, 3, and we would just be left with 2. Form a pair with nums of 0 and nums of 1, and remove them from nums. Now nums. No more pairs can be formed. A total of 1 pair has been formed, and there are 0 numbers left. Okay. So if I go 1, oh, wait a second, I don't know. 3 pairs have been formed. Okay, yeah. So if we do, okay, so let pairs equals 0, and how many numbers are left? 0 numbers left over. Okay, so pairs 1, 1. We find 1, 1, and we remove that. That's 1 pair. Remove this. That's 2 pairs. Yeah, there you go. Remove that. That's 2 pairs. This is nothing. Remove this. That's another pair. That's 3. And now there's 1 thing left. So this is a classic example for a stack. So what we can do here is we can say const stack or pair stack, pairs stack is equal to this empty array. I'm also going to sort these numbers so it's easier to operate on. Nums.sort a b, this is a minus b, and perhaps there's a way to do it without sorting, but I mean, and maybe that's the trick, but I'm happy with doing it this way. Let's do for const n of nums. So if, let's see, if it's empty, let's see, we can actually always push, right? So pairs stack, oh, for n of sorted nums, pair stack dot push n if pairs stack dot length is greater than 0 and pairs stack at pairs stack dot length. Let me put this on a separate line, or maybe just increase the window here. Pair stack dot length minus 1. Pair stack dot length is greater than 0 and pair stack at pair stack dot length minus 1 is equal to n. Let's just do pairs stack dot pop, and we'll also have a count for our pairs. Here we can say pairs plus plus, and then we'll just return, let's do pairs and pairs stack dot length. Sort of like I did this one a little bit quick, 7 and 0. Obviously that's not right. So let's see what's wrong here. This one came up with this one. So sorted nums and pair stack. Let's see this again. And now let's do what? 1, 1. We have 2, 2, 2, and 3, 3. So we get to n first, and we get to our stack up here. So pairs.stack push n, so we push 1. If pair stack.length is greater than 0 and pair stack at pair stack.length minus 1 is equal to n, then we pop. Okay. Oh, but then we need to only do that. Yeah, I only ever want to pop if I definitely don't want to do it just if stack is empty, right? So like I push this one, then I should just go to the next one immediately. If pairs.stack.length, so let's see, if it's not so much that it's like, yeah, let's think about this for a second. I wonder if I can also just increase this. No, I think this will be easier. We push one, and then we go to the next one. Right before we push it, we should just pop it. So maybe this should be, maybe that should be the first thing that we do, right? Else pair stack dot push n. Let's try this out. 3, 1. So the bottleneck here is going to be that sorting, right? So we know that in Chrome, in the V8 engine, we use quicksort, and that's going to be n log n. That's going to be the bottleneck here. The space complexity, well, once we're done with this, oh, 100%. Very nice. 100%, that's like, don't always get that, so very happy about that. Yeah, that will be the space complexity, or I'm sorry, time complexity, and the pair stack, I guess this will, if like, I guess I'll, like if there's every pair, if we have like an array of size 8 and there's 4 pairs, then pair stack will only ever grow, well actually only ever grow to be the size of 1, because it'll find a pair and then it'll push off. But if there's no pairs, it can grow up to the size of the input array, right? It'll just keep pushing on and on and on. We'll never find any pairs. So it's linear space complexity with a n log n time complexity. Now I'm willing to bet divide and mod, but times 2, div and mod the counter, divide and modulo. Obviously better ways here that we can do it. Divide and modulo, is that because, yeah, I guess we can keep a counter of all these. And then at the end, right, so like we have 2 1s. How many 2s do we have? 3. And we have 3 2s. So, right, we have 2 1s, 3 2s, and 2 3s. So that's even, and then we can make a pair of this and we just have 1 left. Yeah, another really good way of doing it. I like using the stack method because this sort of pattern comes up a lot in other questions, so we get some nice practice here, and then it's just good for us to know. So we started today's session with 67 questions. That's why I never refresh this page. So at the end, we see how many we did. So we're currently sitting, wow, at 74 questions. That's a lot. That means we're at 26 questions left to be able to hit our 100 question milestone. So for anyone that was watching today, I'm very excited that you all got a chance to watch. Stay tuned. I'm going to be continuing to put out, notifications of my next stream, so I hope you all can watch it with me. I'm very excited for us to do all this together. We're getting to that 100 question milestone, so I think that's really neat. Hopefully you all learned something from this. Happy to see you all here. Happy coding, and I will see you all next time. Later.